Welcome to Super Easy Physics and Mathematics, SEPAM. Get set as Mr. Matthew Orisheje take you through the detailed step-by-step explanation of IGCSE Physics Paper 4 Extended October, November 2023 Variant 1 examination. Must watch before your exams. This paper is for 1 hour 15 minutes. You are expected to answer all the 10 questions with the total of 80 marks. Question 1. On energy conversion and momentum. A girl holds a rubber ball out of a window of a tall building. The mass of the ball is 0.20 kilograms. The ball is at rest 10 m above a concrete path. 1a. Calculate the gravitational potential energy of the ball relative to the concrete path. 2 marks. Gravitational potential energy, G, is equal as x strength of gravity x height, equal to 0.2 multiply 9.8 multiplied by 10, equal to 19.6 joules. Question 1b. The girl releases the ball and it falls towards the path. The ball strikes the path and bounces vertically upwards. Figure 1.1 shows the ball falling towards the path. The speed of the ball immediately before it strikes the path is 14 meters per second. The speed of the ball immediately after it strikes the path is 12 meters per second. Question 1b. I. Calculate the kinetic energy of the ball immediately after it strikes the concrete path. 2 marks. Kinetic energy equals half mass multiply velocity squared, equal to half of 0.2 multiply 12 raised to power 2, equal to 0.1 multiply 144, equal to 14.4 joules. Question 1b. 2. Show that the change in momentum of the ball when it bounces off the path is 5.2 kg/meter per second. 3 marks. Change in momentum is equal to final momentum minus initial momentum. Change in momentum is equal to mass multiplied by change in velocity, v minus u, equals 0.2 minus 12, 0.2 plus 14 minus 2.4 dash plus 2.8 equals 5.2 kg per second. The negative sign shows that the ball is bouncing upwards. Question 1b. 3. The ball is in contact with the path for 0.25 seconds. Calculate the average resultant force on the ball when it is in contact with the path. 2 marks. Force is equal to impulse divided by time of impact, equals minus divided by equals 5.2 divided 0.25 equals 20.8 Newton equals 21 Newton. Question 1 has the total of 9 marks.
Question 2 on modes of thermal energy transfer. A copper cooking pan contains water. Figure 2.1 shows the pan on a hot plate of a cooker. Copper is a metal. Question 2a. Thermal energy is conducted through all solids by lattice vibrations. Describe one other way in which thermal energy is conducted through the copper. 3 marks. Answer. Heat is conducted through copper through the flow of free or delocalized electrons. The electrons gain thermal energy from hot plate and hot particles. The electrons move throughout copper or electrons move to distant particles of copper. The electrons transfer energy from higher temperature region to lower temperature region by colliding with distant particles, thereby transferring energy to distant particles. Question 2b. The outside surface of the cooking pan is kept clean by regular polishing. Explain one other advantage of keeping the surface of the pan shiny. 2 marks. Answer. Shiny surfaces are poor emitters of radiation. Shiny surfaces reduces energy loss from the copper pan, thereby making less energy transferred to surroundings. Question 2c. The thermal energy passes into the water through the base of the pan. Identify the main method by which thermal energy is transferred throughout the water. 1 mark. Convection is the correct answer. Question 2 has the total of 6 marks.
Question 3 is on pressure under liquid, mass and weight. Liquids are difficult to compress, whereas gases can be compressed easily. Question 3a. Explain, in terms of particles, why it is difficult to compress liquids. For 2 marks. Answer. Particles of liquid are touching each other because the particles are close to each other. The forces of repulsion between particles of liquid are large. Question 3b. Figure 3.1 shows a rectangular block floating in water. The density of the water is 1,000 kg per cubic meter. The area of the base of the block is 0.014 square meter. The base of the block is at a depth of 0.087 meter below the surface of the water. Question 3b. I show that the pressure due to the water at the base of the block is approximately 850 Pascal. For 2 marks. Pressure equals density x strength of gravity x depth. Pressure equals rho x g x d. Pressure is equal to 1000 times 9.8 times 0.087. Pressure equals 852.6 Pascal. Pressure is approximately 850 Pascal. Question 3b. 2. Calculate the force F on the base of the block caused by the pressure given in 3b. I. For 2 marks. Force equals pressure x base area. Force equals 850 Newton per meter squared multiplied by 0.014 meter square. Force is equal to 11.9 Newton. Force is approximately 12.0 N. Question 3b. 3. Calculate the mass of the block. For 2 marks. Mass is equal to weight of block divided by strength of gravity. Mass equals 12 Newton divided by 9.8 Newton per kilogram. Mass is equal to 1.22 kilogram. Question 3 has the total of 8 marks. Question 4. A radio transmitter is a very tall, thin cylinder. It is prevented from falling over by wires which have one end fixed to the transmitter and the other end fixed in the ground. The ends of the wires in the ground are a long distance from the transmitter. Figure 4.1 shows the transmitter and 2 of the wires. Question 4a. The center of gravity G is shown on figure 4.1. Question 4a. I. State what is meant by center of gravity. For 1 mark. Answer. Center of gravity is the point where all the weight seems to X. Question 4a. 2. Explain why the radio transmitter without the wires is a very unstable structure. For 1 mark. Answer. A small tilt on the pole or rotation produces moment that topples transmitter. Question 4b. Wire W is under tension and it exerts a force T on the transmitter. Question 4b. I. On figure 4.1. Mark an arrow to show the force T exerted by wire W on the transmitter. For 1 mark. Answer. The force T exerted by wire W on the transmitter acts downward along the wire. Question 4b. 2. The force T produces a moment on the transmitter about its base. Describe how the moment produced by T is calculated and indicate on figure 4.1 what is meant by any other terms in the description. For 3 marks. Answer. Moment equals force multiplied by perpendicular distance from pivot. Moment is equal to the product of force and perpendicular distance from the pivot, where force F is equal to tension T multiplied by sine theta. Question 4c. The radio transmitter uses radio waves to transmit radio and television programs. State 1 other use of radio waves. For 1 mark. Answer. It is also used for a mobile communication between mobile phones and base stations, radar and navigation systems, satellite communication, a Wi-Fi connections, a Bluetooth connections, a medical imaging, MRI scans, industrial heating processes, and radio frequency identification, RFID. Question 4 has the total of 7 marks. Question 5. Many methods of generating electrical power involve the use of water. Question 5a. Describe 1 method of generating electrical power from energy stored in water. For 3 marks. Answer. This method is called hydropower. Here's how it works. The energy used comes from the gravitational potential energy stored in the water held behind a dam in a reservoir. The higher the water level, the greater the potential energy. The dam controls the water's flow, converting the potential energy into kinetic energy as the water falls towards the turbines. The moving water then strikes the blades of a turbine, causing it to rotate. This rotation of the turbine shaft is transferred to a connected generator, which converts the mechanical energy of the spinning turbine into electrical energy. Question 5b. For the method you chose in A, state one advantage and one disadvantage of generating electricity this way. For 2 marks. Advantages of hydropower. A clean and renewable. Hydropower is a clean source of energy because it doesn't produce greenhouse gases or air pollution during electricity generation. The water used is continuously replenished through the natural water cycle, making it a renewable resource. Disadvantage of hydropower. Environmental impact. Building dams for hydropower can significantly alter the surrounding environment. This can disrupt fish migration patterns, flood ecosystems, and displace local communities. Changes in water flow and quality can harm aquatic life. Question 5c. State 2 methods of generating electrical power for which the main source of energy is not the sun. For 2 marks. Answer: nuclear power. This method uses nuclear fission, the splitting of atoms, to generate heat. This heat boils water to create steam, which then spins a turbine and drives a generator to produce electricity. The primary energy source isn't the sun, but the energy stored within the nucleus of atoms in nuclear fuel, like uranium. Fossil fuel power plants. These plants burn coal, natural gas, or oil to create heat. Similar to nuclear power, the heat boils water to create steam, which spins a turbine and drives a generator to produce electricity. The energy source comes from the chemical energy stored within the fossil fuels, not the sun. Geothermal power. This method utilizes heat from the Earth's core. Geothermal power plants tap into underground reservoirs of hot water or steam. This steam can then directly spin a turbine or be used to boil water and create even more steam to drive a turbine and generate electricity. The heat source is the Earth's internal heat, not the sun. Tidal power. This method uses the energy of moving tides. Tidal power plants use underwater turbines that capture the kinetic energy of rising and falling tides. As the tide moves in and out, the water pushes against the turbine blades, causing them to rotate. Question 5 has the total of 7 marks. Question 6a. Page of printed text is placed 18 centimeters from a converging lens of focal length 35 centimeters. Figure 6.1 is a scale diagram of the arrangement, with each of the 2 principal focuses, focal points, of the lens labeled F. Question 6a. A length of 1 centimeter on the scale diagram represents an actual length of 5.0 centimeters. Question 6a. I. By drawing on figure 6.1, locate the image of the page produced by the lens and label it I. For 3 marks. Answer: from the top of the text, the red ray of light parallel to principal axis is refracted by the lens and passes through the focus F to the right. From top of the text, the green ray passing through the optical center of the lens is unrefracted. To the right of the lens, the rays are diverging, so the rays can never meet. To the left-hand side of the lens, the rays appears to converge. Therefore, on extending the red ray and the green ray, they intersect further to the left. At the point of intersection, an enlarged virtual image of the printed text is formed. Label the image I. Question 6a. 2. Using figure 6.1, determine the actual distance of image I from the lens. For 2 marks. Answer: the actual distance of image I from the lens, V, is 38.5 centimeters. Question 6b. Converging lenses can be used as magnifying glasses. State whether the image produced when a lens used as a magnifying glass is real or virtual. Explain why. 1 mark. The image is virtual because the image cannot be projected on screen. Real light ray does not pass through image and light only seems to come from image. Question 6c. Suggest how someone who is long-sighted may benefit from using a converging lens. For 2 marks. Answer. Long-sightedness focuses image behind retina, or long-sightedness produces blurry images of close objects. Converging lens reduces focal length of eye. Converging lens puts image further away from the eye. Converging lens gives sharp image on retina. Question 6 has the total of 8 marks. Question 7 is on electrostatics. Question 7a. A plastic rod is uncharged. When the rod is rubbed with a woolen cloth, the rod becomes negatively charged. Explain, in terms of particles, why the rod becomes negatively charged. 2 marks. The rod becomes negatively charged because electrons move from cloth to rod. Question 7b. Figure 7.1 shows a negatively charged metal sphere S. There is an electric field surrounding S. Question 7b. I. State what is meant by an electric field. 1 mark. Answer. Region around S where an electric charge experiences a force. Question 7b. 2. On figure 7.1, draw the pattern of the electric field surrounding sphere S and indicate its direction. 2 marks. Answer. The electric field surrounding sphere S points towards the sphere S. Electric field lines enters a negatively charged sphere. Question 7c. Figure 7.2 shows a small negative charge Z placed near to sphere S. Charge Z experiences a force due to the electric field surrounding sphere S. On figure 7.2, draw an arrow to show the direction of this force on Z. 1 mark. Charge Z placed in the electric field of negatively charged sphere S will be repelled. Question 8 is on resistance of wire, charges flowing in a conductor and current flowing in a circuit. Question 8a. Cylinder is made of modeling clay. The modeling clay is an electrical conductor. Figure 8.1 shows the cylinder S cross-sectional area and length. The cylinder is connected into a circuit. Figure 8.2 shows that the circuit also includes a battery of electromotive force EMF of 9.0 volts and a resistor P. The resistor is connected in series with the modeling clay. The resistance of P is 4 ohms. The current in P is 1.5 amperes. Question 8a. Calculate. Question 8ai. The magnitude x of the charge that flows through P in 600s. For 2 marks. Quantity of charges equals x. Q equals 1.5 ampere multiply 600 seconds. Q equals 900 coulombs. Question 8ai. The resistance of the cylinder of modeling clay. For 3 marks. Electromotive force equals IRP plus IRC. 3 volt equals 1.5 ampere x resistance of cylinder. Resistance of cylinder equals RC equals 3 volt divided by 1.5 ampere equals 2 ohms. Resistance of cylinder equals 2 ohms. Question 8b. The cylinder is removed from the circuit and replaced with a new cylinder made of the same modeling clay. The new cylinder is twice the length and has half the cross-sectional area of the first cylinder. Calculate the time that it now takes for a charge of magnitude x to flow through resistor P. For 4 marks. R2 is proportional twice the length and R2 proportional to reciprocal of cross-sectional area divided by 2. Resistance of the wire is equal to product of resistance and length divided by cross-sectional area. Equals resistivity x2 length divided by half of area. Equals 4 times resistivity x length divided by cross-sectional area. Total resistance equals 4 ohms plus 8 ohms equals 12 ohms. Current equals 9 volt divided by 12 ohms equals 0.75 ampere. Quantity of charges equals x equals 900 coulombs. 0.75 ampere x equals 900 coulombs. Equals 900 coulombs divided by 0.75 ampere equals 1,200 seconds. Time equals 1,200 seconds. Question 8 has the total of 9 marks. Question 9 is on radioactive isotope. Question 9. Many household smoke alarms contain a sample of the radioactive isotope americium-241 Am. Question 9a. Americium-241 is the isotope of the element americium that has the nucleon number or mass number of 241. Note: mass number is equal to the total numbers of protons and neutrons in a nucleus of an atom. Question 9a. I. State how the composition of a nucleus of americium-241 differs from that of a nucleus of americium-242. For 1 mark. Answer: americium-241 has 1 neutron fewer in the nucleus compared americium-242. Question 9a. 2. An atom of a different element has a nucleon number of 241. State 2 differences between the composition of a nucleus of this atom and a nucleus of americium-241. For 2 marks. Answer: the nucleus of the element has different number of protons in its nucleus. The nucleus of the element has different number of neutrons in its nucleus. Question 9b. Americium-241 decays to an isotope of neptunium, Np, by alpha particle emission. Question 9b. I. Complete the equation for this decay. For 3 marks. Americium-241 with the atomic number of 95 decomposes to neptunium-237 with atomic number of 93 releasing alpha particle which is helium-4 with atomic number of 2. Question 9b. 2. One reason for using an isotope that emits alpha particles in a smoke detector is that alpha particles are more strongly ionicing than beta particles. Explain why alpha particles are more strongly ionicing than beta particles. For 2 marks. Alpha particles have more kinetic energy than beta particles. Alpha particles have more charge than beta particles. Question 9b. 3. The isotope of neptunium produced by americium-241 is also radioactive. The decay of this isotope of neptunium produces an isotope of protactinium which decays by beta particles emission. Beta particles are more penetrating than alpha particles. The half-life of neptunium is longer than 2 million years. Using this information, explain the advantage of this long half-life for the use and safe disposal of a household smoke alarm. For 2 marks. Answer: few emissions per unit time. So smoke detectors are not hazardous to humans. So disposal of old detectors is cheap and easy. The total marks for question 9 is 10 marks. Question 10. The Milky Way is one of many billions of galaxies. Each galaxy contains many billions of stable stars. Question 10a. Stable stars transfer energy into space by emitting electromagnetic radiation from their surfaces. Describe what happens in the core of a stable star to release energy that is eventually transferred into space. For 3 marks. Answer: hydrogen nuclei fuse to become helium nuclei. Nuclear fusion occurs in the core. Hydrogen fuses into helium releasing radiate energy. Question 10b. On the Earth, light from a distant galaxy is observed and analyzed by astronomers. This information is used to determine the speed at which the galaxy is moving away from the Earth. Question 10b. I. Describe how the observed light is different from when it was emitted. For 2 marks. Answer: the observed wavelength is longer. Wavelength is shifted towards the red end of the spectrum. The light from galaxy is red-shifted or shifted towards red end of spectrum. Question 10b. 2. State the quantity that astronomers use to determine the speed at which the galaxy is moving away. For 1 mark. Answer: change in wavelength or starlight due to redshift. Change in wavelength divided by wavelength equals yxy divided by Question 10c. The Hubble constant h0 is equal to 2.2 times 10 raised to power negative 18 per second. Question 10c. I. Calculate the distance from the Earth of a galaxy that is moving away at a speed of 1.3 times 10 raised to power 7 meter per second. For 2 marks. Hubble's law states that the velocity, v, of a galaxy receding from Earth is proportional to its distance, d, from Earth. Velocity of galaxy equals h times distance from Earth. Distance from Earth equals velocity of galaxy divided by Hubble constant. Distance from Earth equals 1.3 times 10 to the power of 7 divided by 2.2 times 10 caret minus 22 equals 5.90 times 10 to the power of 28 meter. Question 10c2. Calculate an estimate for the age of the universe. Give your answer in years. For 2 marks. One way to estimate the age of galaxy, t, is to take the reciprocal of the Hubble constant, h. Age equals 1 divided by Hubble constant equals 1 divided by 2.2 multiply 10 raised to power 18 equals 4.5 times 10 raised to power 17 seconds. Age converted to years is equal to 1.4 times 10 raised to power 10y. Question 10 has the total of 10 marks.